You know the feeling, right? You build this storage solution, it looks absolutely perfect on paper, but the moment it hits the real world, it just crumbles under pressure. Well, today we're diving into how to design VMware solutions that are genuinely resilient. And this isn't about chasing shiny features, it's about building something that can actually survive the chaos of a real production environment. Let's get into it. All right, so here's our game plan. We're going to start with what I call the day two problem. That's basically why things tend to break after the initial setup. Then we'll walk through a simple four-question model that'll guide your designs. We'll also dig into the different ways to think about vSAN versus external storage, and of course, point out some common traps you'll want to avoid. And we'll wrap it all up by talking about the kind of mindset that brings this all together. So let's jump right in with the core issue here, the day two design problem. This is that moment where a design that seems totally flawless in a lab meets the messy, unpredictable reality of a live environment. I mean, we've all had that sinking feeling on patch night, haven't we? You kick off a totally routine update, and then boom, performance just tanks, alarms start going off everywhere. It's a classic sign that your design was missing something really important. And here's the answer. It's because the design was only built for the happy path, for that steady, predictable workload on a normal, quiet afternoon. It completely ignored the operational realities of what always comes next. And that's exactly what day two operations is all about. It's the real world. It's that relentless cycle of patching, of growth, of hardware failures, and unexpected new workloads. A truly resilient design isn't just about surviving this stuff. It's about thriving in the middle of that storm. So how in the world do you prepare for that storm? Well, it all starts with a really simple but incredibly powerful framework. A four-question mental model that's going to lay the foundation for a design that can actually hold up. Before you even think about opening Visio to draw a diagram, you've got to ask yourself these four questions. First, what's our storage foundation? Are we talking vSAN or external? Second, what are the absolute non-negotiables, things like availability and performance? Third, what are our constraints? Hardware, network, budget, you name it. And maybe most importantly, number four, how are we going to prove that it actually works? And this really gets to the heart of it. The best design isn't the one that's the fastest on paper or has the most features. It's the one that is supportable, consistent, and verifiable through its entire life cycle. Okay, let's get a bit more specific. First up, vSAN. When you're designing with vSAN, the mindset is fundamentally different from traditional storage. It is all about declaring your intent. Think of it this way. With vSAN, you basically tell the system what you want. You create a policy that says, hey, this workload here needs to survive a host failure, and it needs to maintain this level of performance. Then the system figures it out. But with external storage, you are responsible for making sure every single component in the chain, networking, access paths, is perfectly consistent to get that same result. Two totally different ways of thinking. And the tool you use to declare that intent in vSAN is called Storage Policy-Based Management, or SPBM. This is the magic. This is where your design decisions, your availability targets, your performance goals get translated into a living, breathing configuration that the system enforces for you automatically. Now, let's flip to the other side of the coin, designing with external storage. If vSAN is all about declaring your intent, external storage is about one thing: obsessive consistency. Seriously, even the smallest, most minor inconsistency here can create a hidden time bomb. Every single host in that cluster must have identical network configurations, identical access controls, and identical pathing. Any deviation at all just introduces a huge amount of risk. Now, here's a question that applies whether you're using vSAN or external storage, and it's one that gets overlooked almost all the time in the design phase. And that question is, what's your repair budget? A repair budget isn't about money. It's about the resources you've set aside for when things inevitably go wrong. So, do you have enough spare capacity to actually rebuild data after a disk or a host fails? Do you have enough performance headroom to handle both your normal user traffic and the massive I/O that comes from a data resync? And maybe the most critical question, can you recover fast enough to get back to a fully protected state before the next failure happens? This is what separates a robust design from a fragile one. Thinking about these repair budgets actually helps us avoid some major pitfalls. So let's look at the four most common design traps that you really need to watch out for. Okay, number one, and we've hit this one hard already, is designing only for the happy path. Number 2 is underspecifying or skimping on the network. The network is the absolute backbone for modern storage. It's a huge source of those mysterious performance issues. Third is a fundamental mismatch, using a technology that just doesn't align with your operational goals. And finally, failing to define what good actually looks like. If you don't know how to verify your design works, you'll never be able to troubleshoot it when it doesn't. So all of this really leads us to the core philosophy, the key takeaway here, which is adopting a resilient design mindset. If you remember just one thing from all of this, please make it this. The goal isn't to build something with the longest possible feature list. The real goal is to build something that has the lowest risk over its entire life cycle, something that survives patches and upgrades and failures and growth without creating constant fire drills for you and your team. So you've got to shift your thinking. A design document isn't just a blueprint for day one, it's your survival guide for everything that comes after. It's built to anticipate the storm. And that leaves us with one last question for you to think about in your own environment. Take a really hard look at your designs. Are they built assuming clear skies and calm seas? Or are they truly, genuinely ready for the inevitable storm of day 2 operations?